We will begin our session shortly. Um, Welcome back, ladies and gentlemen. I hope you have all had a refreshing lunch break. We are now ready to resume our workshop with two more insightful sessions this afternoon. The first session will be a 30-minute presentation by Dr. Yoshitaka Ushio from the Energy Conservation Center of Japan, or ECCJ. Uh, Dr. Ushio, the time is yours.
Okay. Ladies and gentlemen, good afternoon. My name is Yoshitaka Ushio, Energy Conservation Center Japan. I myself working for the energy conservation promotion in overseas for more than 20 years in this organization, and especially for ASEAN countries, ASEAN member states. I'm most of the my work for energy efficiency and conservation policy and some techniques for the ASEAN member states. My title, presentation title, Introduction of JS World Activities and Sharing the Practices in Japan for Disseminating Zero Energy Buildings. Next, please. First of all, I would like to, explain the JSW first, and then I will explain the main theme of my presentation for the dissemination of Z. JSW was established in 2008 with a strong support from METI, Ministry of Economy, Trade, Industry in Japan, and the Japanese Business and Industry Association, Keidan-ren. Its mission is that in cooperation with the government, Japanese business company will make specific contribution to the global environment and carbon neutrality by disseminating Japanese advanced energy and energy efficient technologies and products to the world. And the ECCJ is the secretariat of this organization. Next, please. Is this moment around SW. Next, please. And also, this slide shows the observers and associates members of the JSW. So observers, for example, Ministry of METIS and JICA or JETRO and so on, and the associated member with various Japanese Industry Association, and also ECCJ is associate members. Next, please. The JS World has several working groups working on the specific topics and regions. The most active working group is the Zero Energy Building Solution Working Group, which hold a seminar today by supporting of MEMR. As realization of zero energy building should be key issue for carbon neutrality. The JSW established a working group several years ago and has been cooperating with and supporting the promotion of ZEB in ASEAN countries. One of the outcomes of working group activity to date is facilitating to make the global standard ZEB and has successfully enacted as an ISO technical specification ES23764 since 2021. Next, please. The active energy transition and carbon neutrality of Asia, the government of Japan advocated the initiatives of AZEC, ASEAN Zero Emission Community in 2021, and JSW nominated 5 working groups to support the AZEC activity. The left figure shows the image of achieving net zero community Asia, and this one is already METI presentation is introduced this project. Next, please. The JSW is also publishing rate every year, which compiled various smart energy products and technologies developed by Japanese companies and applicable to the world. And I think you can get the brochure of the JSW in the reception. So you when you go back, please take this, brochure on the reception desk. Okay, next please. So then move to the main theme of the my presentation. Say dissemination of zero energy building in Japan. So this graph shows Japan's final energy consumption and GDP since 2073, the year of oil shock, and shows that the piece of GDP energy intensity is largest in residential and commercial sectors. Japanese government, sorry, next please. Next. So residential and commercial sector, the Japanese government has been making efforts to promote energy conservation in these sectors. So next please. So for achieving carbon neutrality in 2050 and this new reduction target for the 2030, on October 2021, the government released Japan's strategic energy plan. For the energy efficiency, the new strategy energy plan aimed to achieve 62 million kiloliter oil equivalent energy saving. The new target, 62 million kiloliter oil equivalent energy saving, require further 40% energy efficiency improvement from 2013 and to 2030, which is the same saving rate from 1970 to 1990. It's just after the oil shock. So then, next please. And for the this slide shows the specific measures and the initiatives in each sector to achieve the energy saving target, 60 million kiloliter oil equivalent in 2030. Energy saving building, energy saving building, zero energy building is the most important policy in commercial sectors. Next please. So then I will explain to the more detailed activities, initiatives, and the dissemination of zero energy building in Japan. Next, please. This is the background of the ZEB dissemination in Japan. Looking at the real situation in the commercial building sector, the current ENC measures and regulatory framework cannot achieve COP21 target in Japan. Therefore, this challengeable target realize zero energy buildings in average newly constructed public and private buildings by 2030 has been set in order to promote and disseminate high-level energy efficiency buildings, ZEV ready first, and realize net ZEV by step-by-step approach through the continuous effort. Next, please. Oh. Right. Sorry. Next, please. Okay. So in Japan, we had many kind of the measures implemented in the for the realization of zero energy buildings. I think the most important thing how to disseminate. So the various the activities now going on. The firstly, one item is a definition of zero energy buildings. So this present zero family concept, zero ZEV family concept, which is a process to achieve the net zero by step-by-step approach. The concept of zero has been expanded to the ZEV series. So approach according to actual conditions. First step is to aim for super energy efficient building, which are defined as ZEV ready, and then aim for nearly ZEV and the net ZEV by applying further energy efficient measure and the introduction of the renewable energies. Okay, next, please. So this presents how to evaluate and classify the building into the three levels: ZEV ready, nearly ZEV, and net ZEV. And this graph show also baseline is very important. Baseline. So in Japan, we have already the primary energy consumption standard, and each building have standard values. So, but I think depend on the country's condition. Maybe this baseline is determined according to their conditions, and this is very important. So from baseline point, and then horizontal axis is energy consumption, and vertical axis is generation of electricity or energies, electricities. And first do the energy efficiency to this case to 50%. In this Japanese standard is a 50% deduction, and then the building becomes a family of the family of the ZEV family, and then after that you put more energy efficiency and also put renewable energy. So vertical axis is renewable energy, and then you can get the nearly ZEV and also net ZEV finally. So these are how to evaluate. So basically, important point is baseline and how many percent to be reduced for energy efficiency, and then how much energy, renewable energy, involved in this building. So then evaluate these three levels. Next, please. But you can understand. I think big buildings, high-rise building, or maybe airport terminal building, or maybe normally big building, and or more complicated building like a hospital, maybe hotels. So such case, 50% energy efficiency is very difficult. So that's why if you know only that previous slide evaluation, I think a big building is very difficult to achieve the ZEB series, ZEB family buildings. So that's why for big building, so that is means 10,000 square meter or floor area, they have another categories and another level. We call ZEB oriented. So the like office and the school and factories, they are if they are uh, 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 40%, uh, uh, 30% achieved it. We call this become the group of dev oriented, and uh, the hospital and hotels, the 40%, 40%. Sorry. Sorry, 30% for the office. Sorry, hotel and hospital, and 40% is office and school, and then there becomes a group of the ZEB oriented. So now in Japan we have four type of the zero energy buildings: ZEB oriented, ZEB ready, nearly ZEB, and net ZEB. So whole these building say zero energy building. So then the people to understand how to how to promote zero energy buildings. So but one requirement to be added. So these buildings must apply one advanced technologies. I just listed in the right hand side, listed new some technologies, special set technologies, which are not the incorporated in the Web Pro. Like that this morning Dr. Miyata-san explained. That's the Web Pro not included these technologies. That's why these technology, one of these technology must introduced in these buildings. That is the ZEB oriented. Next, please. So that's why this is the evaluation and classification method. We are same previous slide show that like this. Okay, next please. So this is ZEB reading owner and ZEB planner registration system. This is a very now effective for the dissemination for the zero energy buildings. The government built a system, ZEB leading owner registration and ZEB planner registration to promote and disseminate ZEB. The building owner have actual cases of zero energy building or specific plan of ZEB construction are registered as ZEB leading owner, and they release their information on their ZEB building case to create new owners. So this show like this. And in addition, the building owners can start with the design companies, consulting companies, or maybe construction company, or who have knowledge of ZEB, etc., as ZEB planners who are registered. So the ZEB planners should have wide range of the consulting channel for the realization of ZEB and publish their experiences and the knowledge on building design, etc., activity to the general public. So now this two registration system, so they can building owner, even the planners, they can get the information from the each communication. So that kind of system is now going on, and now ZEB planner is 775 companies, and ZEB leading owner 749 cases as of February of this year. Next, please. Next one is this is already Dr. Miyata-san already explained. This is labeling system, including ZEB, we call building energy labeling system. So BERS, this in order to promote and stimulate building with high energy saving performance, various environmental performance labeling and certification system are going on in Japan. This year, the label is revised for the considering ZEB series and renewable energy application. 6 star, not 5 star, 6 star, 6 star shining stars and renewable energy promotion. So this is a non-residential building. This is a left-hand side, which show some criteria. So if the energy saving and also the renewable energy more than 50%, so then they can get the 6 stars. But what is the also this stars showing the how much renewable energy applied. So then shining star is just right hand side. The shining means the renewable energy is some percent like that. So maybe 2 shining star more renewable energy applied. 3 star more energy renewable energy. So more than 50% energy saving and renewable energy reduction, and then they can get the 6 stars. So that kind of system, and also put the zero energy ZEB ready or nearly ZEB or ZEB orient or net ZEB is showing this label. Okay, this label is now the just a little bit old record, but as of May last year, 5,069 cases, and ZEB series is 2,564 cases, and the percentage of ZEB series is 50.6%. So I think in Japan you can understand the ZEB zero energy building is a destination going well. That is the showing this labeling system. Okay, next please. Award system. In order to further enhance awareness of ZEB and impress upon building owners and investors, the framework of the energy conservation grant prices, which is already widely recognized as an award system for appliances. Next please. Previous one. Sorry. Previous. So this is the energy conservation grant prize, which is already widely recognized as an award system for home appliance, and energy management practice will be utilized. The ZEB and ZEC is zero energy house field was newly established in the energy conservation best practice category and product and business model category in 2021. This award system has been conducted by the ECCJ, and myself is a member of the judging in the category related to them. Next, please. Sharing and accumulation of knowledge capacity building for engineers. The ZEB design guideline for design engineers and architects, let's say ZEB planners, and the ZEB brochure for the building owners. This is the ZEB leading owners. And as a business operator has been prepared and available on the website. The English version of some of them are available, and if you want to get, please request to JSW. So I think this is the quite specific description of the to achieve the zero energy building. So by design. So I think if you want to maybe ask Yamamoto-san, there we have some maybe office, hospital, and school, so you can contact with Mr. Yamamoto. Okay, next please. Okay. For standardization of the this step-by-step approach towards ZEP, this concept was approved by the DTS ballot during December 2020 to 12th February 2021, and the 5th March to 5th May 2021 is ISO TS 2205. And this specification TS23764 is issued the uh, September 2021. The purpose of the standardization is improve the practicability for ZEV by promoting the ZEV family concept, which allows step-by-step approach to net zero energy building and to increase dissemination rate by realizing ZEV family building to satisfy part of all the requirement necessary to achieve the net zero energy building. So this is specification titles methodology for achieving non-residential zero energy buildings. These are now the available. Next, please. これも入ってないね。Sorry, this is, I think the graph is missing, but I think the same graph for evaluation classification of the zero energy building is mentioned in this TS technical specification. But the energy efficiency ratio in Japan, we say 50%, and for ZEB ready, and then nearly ZEB is 75%. That one is not, fixed. We say alpha and beta, say in this specification. So depend on the condition of the each country, they can choose these, numbers. Okay, next please. And this specification also shows the 6 core elements to the non-residential building, zero energy buildings. And the step-by-step approach, like at the planning stage, at the design stage, and during construction, and after completion of the building, after the startup of the operation, and these, the key issues are mentioned in this, core element, the description. Next, please. So you can see, I think this is Indonesia, like best practices which were awarded in ASEAN Energy Award. This, ISO TS23764 are now under revising. So what is the, main purpose for revise is we are, we have lots of, the support from ASEAN countries to develop this specification. And so then we added ASEAN cases in this specification. This is under, now, reviewing, and finally, end of this year, this, revised one will be issued. And this is the cases in Indonesia. So 3 cases are, added, ASEAN 3 cases added in this specification. I think maybe this is a quite, quite, the useful information for us. Okay, next please. Next please. So then I will explain about like some activity to ASEAN. So to ASEAN, the AGEP program, ASEAN Japan Energy Efficiency Partnership Program, and the JSWORD program implemented many activities to promote ZEB family concept since 2017. Last year, Thailand, Vietnam, Philippines, etc. And the workshop on ZEP and building code in Japan, we call ECAP 33 in October by inviting the trainees from ASEAN member states. We will continue this activity in ASEAN, and first seminar this year is today's one. And also this year, fiscal year 2021, we have some other seminars in other countries. And also, please bear in mind, we have ECAP 36. ECAP is the Energy Conservation Workshop under AGEP. This was implemented in Japan. So we have a discussion on new ZEV category in ASEAN Energy Award. And also, I'm now planning to the practice for the Web Pro, which is presented this morning, and we are preparing the some kind of simple drills practice, and to train to use this Web Pro and calculate the energy consumption. So then one day, this, training is now, planned. So maybe maybe at least one people from each ASEAN member state will be invited to Japan. And the last one is carbon neutrality diagnosis. I think this is now in this year we are now planning to do the Brunei in August. So I would like to explain about this CN diagnosis, and also we are looking for the candidate of the buildings for this, the CN diagnosis. Next, please. Okay. Next, please. So the AGIP Scheme 5, we are doing the CN diagnosis, CN carbon neutrality diagnosis. So we are now develop the CN project promotion. So CN project, the procedures are, mentioned in the 8 items, 8, steps. So normally, the start the like target setting to finally publish the result to the stakeholders. So this, their project, we are now, doing this three steps that are circled by a yellow. Sorry, previous one. Sorry. Yellow line. So that is the CN diagnosis and find the program and the measures. And the second one, calculation of CO2 reduction with emission factor, and set the mid to long-term plan. So this is including industry and building, but building is a little bit different. So that's why we are now, planning the building one. Next, please. So the building, we are, mainly our purpose is the dissemination of zero family concept. So in this CN diagnosis for the buildings, we are, promotion of the understanding of methodology, including a baseline study of E&C buildings and the technology list to realize non-residential zero energy buildings, and formulation of model project to implement CN, E&C measures through CN diagnosis and preparation of implementation plans. So these are kind of outline of this, CN diagnosis of the outline outcomes of the CN diagnosis. Okay, next please. So ZEB is a building that aims to achieve significant energy saving while maintaining the quality of the indoor environment by reducing energy load. So this CN diagnosis for building we call ZEB diagnosis. This is a significant energy saving. I think more than 50% from the baseline. That's on the target to the feasibility study. So this, we can get both the site data, and also we are using a simulation tool, that Web Pro, and calculate the baseline model and also the ZEB models. So next, please. So we have mentioned more, the detailed explanation of the activity of Egypt Scheme 5. So this study proceed with the following steps. One is identify the current building conditions, develop a baseline model of energy consumption that reflect the current building conditions, and run simulation and calculate energy consumption for baseline model, and develop a zero model by applying various energy saving retrofit measures to the baseline model, and run the ZEB model simulation to calculate energy consumption. Various energy saving retrofit measures are applied to ZEB model on the try and error basis, so that the calculated energy consumption of ZEB model is at least 50% or less of the calculated baseline. So energy consumption performance calculation program for non-residential building. This is a Web Pro. This is explained this morning. Is used to create a baseline model and ZEB model, and to simulate calculate of energy consumption. Web Pro is already explained, so you some understand. Dr. Miyata explained. And the CN diagnosis was conducted at the Baguio IRRAN Technofab in Philippines last year, and Paralanco Hospital in Thailand 2023. And this year, ECCJ will conduct CN diagnosis for office building in Brunei Darussalam in coming August. So we are now, looking for the candidate for the this, CN diagnosis, and this activity is one of the capacity building programs linked to the ECAP. I already explained ECAP 36, and this year we are more concentrated for this kind of simulation tool to calculate the energy efficiency more precisely, and to propose very super energy efficiency buildings. So Indonesia, we are already done the industry this CN diagnosis, but the building is not yet. So maybe please apply for the this project through the ASEAN Center for Energy. Okay, so that is my presentation. Thank you very much for this is summary, and thank you very much for your attention.
Thank you, Dr. Ushio, for very insightful presentation. The next is the second session. We will be honored to have 4 distinguished presenters that will discuss the technologies and best practices that support the implementation of zero energy buildings. So we will invite those 4 presenters to come to the front desk. The first one is Mr. Marcus Tan from AGC Incorporated. The second one is Mr. Indo Permana Putra from Sanken Setsubi Kogyo. The third one is Mr. Mumbang Sihite from Asbil Corporation. The fourth one is Mr. Masato Yosomiya from Mitsubishi Electric, that I believe has joined us virtually. So all the speakers have come to the front. Online. Well, let's start the session by inviting the first speaker, Mr. Marcus Tan from AGC Incorporated. The time is yours.
Hello, thank you. Selamat siang. Good afternoon. I'm Marcus. I'm from Singapore. I represent AGC. Today I will share with you about ZEB with using AGC glass solutions and how we can build a green build with efficiency and aesthetic both on board. So for a start, I would like to share about our AGC group, the ZEB concept, whereby we have heard most of the presentations in the morning and afternoon, and our glass solutions, and some case studies which we have implemented to help on these ZEB solutions. First, AGC group, if maybe most of you know us or some of you still do not really know us, we are one of the largest leaders in glass, electronics, chemical, life science, ceramics, and other materials. Total workforce is about 56,000. Mainly, we are looking into architecture glass and also automotive. And also, we have some chemicals for the buildings industries like ETFE film and also electronics, and also some ceramics and other materials like Lumifrom, FEVE resins. In terms of Asia Pacific, AGC Asia Pacific is headquarter is actually in Singapore, and we are looking into the region offices like Malaysia, Vietnam, Indonesia, and also in Thailand as well. In Indonesia, I think most of you will know PT Asahi Mas Flat Glass. So it's actually a joint venture between Asahi Glass in Japan, also PT Rodamas, which also perform PT Asahi Mas Flat Glass as a pioneer in Indonesia. This was established in 1971, which is about 60 in Indonesia. So we do float glass, mirror, safety glass, headquartered in Jakarta. We have factory in Cikampek and also Citaro, and automotive glass in also Cikampek. Today we heard about ZEB concepts. So we know about these energy savings, and the key principles is to have a good passive design strategy, also a high performance building envelope together with this energy efficiency HVAC system, and in terms of smart building technology. So we look into this passive design, active design, smart designs, and in the next level, we are also looking into on-site renewable energy. So with this on-site renewable energy, we are looking into incorporate on-site renewable like solar panels or BIPV, wind turbine, and also other charcoal systems. Looking into energy saving solutions, first we are looking into our AGC coated glass. We have coated glass which meets building codes, high shadings, suitable to meet ASEAN or Asia's climate. We have a range of products. I will go more into it later. And also for energy generating area or solutions, we are looking into a BIPV, which actually integrated seamlessly into the facade and also the glazing design. Actually, it also able to harvest energy and also produce electricity. As years goes by, we see the evolutions of this architecture glass. It started from tinted glass with a high VLT and also a higher HGC value. Then we slowly move into those heat reflective glasses, which actually has a better performance compared with tinted glass. Next, you can see that nowadays we look into low E coated glass or also IGU, having also a good better VLT and also SHGC. And now we are also looking towards building integrated photovoltaic, which can go as good as SHGC as low as 0.15 and also able to harvest solar energy. I will share more in details of why these VLT and SHGC is so important in terms of our wealth and well-being. First, we look into the glass property. So the sun actually emits wave in the form of visual light, ultraviolet, and also infrared. So as a start, you can know or we know that a clear float actually glazing or let these visible light without restricting any other form of wave in the form of infrared or UV. So this actually also hits or build up the cooling effect or the energy cost for the building itself. Then we look into a coated glass, which actually allows better control of these wave penetrations and have a good performance, as you can see from the graph on the right side. And next, we look into the visual property, which is light transmission. So we look into the amount of light that enters indoors. So you can see today we have all the blinds drawn down. We do not have much lights, and it seems like quite cozy or a bit stuffy here. And next we will understand that all these will also impact in light reflections, and the amount of visible light need to be reflected have a better kind of of preference. Solar and thermal protections, SHGC, which I talk about quite often just now. You can see that the product or the percentage of the total solar heat entering through, actually you can see that, for example, the lower the value, the better the shadings it can be. U value, which also represents the insulation effect or heat transfer between the outdoor and indoor. The lower the value, and also the better the insulations. So this actually matters a lot because in terms of energy efficiency, it actually reduces building heating and cooling costs. In terms of good wealth and well-being, daylight and thermal comfort, which also enhance the internal space with good natural lights and also in well-being. And it also gives you a good aesthetic appeal and enhance the building aesthetic quality. In AGC coated glass, we have many range. Yeah, actually one of the world leading technology in terms of interpaint, and also we are able to do jumbo size. We have a good Metatron solar control low E and also offline and online coating. These are low E. We are looking into a good wide range of coated glass, stop ray, stop so, and sun energy and panel belt and all these. So we are also in Jakarta or in Indonesia. We have many project reference that we can showcase these. So first, we look into this top ray vision. This is good as a double glazing with aesthetic neutrality. It reflects the compliance as to in Singapore needs. So these are the range of products we look into in terms of commercial. And it is actually a LEED certified and also a green building product certified. Energy savings in double glazing, energy model, we can see that in terms of energy consumption, it can actually reduce against a float glass comparing with a stock ray vision. And vision 38T will have a better energy consumption. Thermal comfort, you can see that using a float or normal double glazing glass, you still have these hot or these heat solutions. And with a Vision 32 global deglazing, it actually gives you or cool down the building with a good comfort for you. Nature aesthetic, in terms of buildings wise, we can see that these are some of the project reference. It actually blends in well and have a stick aesthetic ideal for commercial or even residential building or even a mixed use building. some project reference in Jakarta. Probably you guys will know more than me about these buildings locations. You can see that all is very, it can stand the time. After so many years, it still looks so brand new and clean. And also, if probably you are inside these buildings, you will feel comfortable and having a thermal comfort. So these are some of the projects we have. Sahimas. Then next, so these are glasses. Actually, we are first in Asia to obtain these EPD certifications, and it's also actually classified as an A-list company for climate change, recognized as a WB2 below 2% climate actions country. So proudly to be a founding partners in the Green Building Council. Next, I will share more in terms of energy generating glass. It's called Sanjo. Basically, it's called Sanjo in Japan and also in Indonesia due to some licensing issues, and it's actually marketed as a Sun Ewok in other countries. Why this is the forward moving is that this is actually a BIPV that actually will be redefining the role of the facade in this kind of building energy system. How it can also do by reducing the energy consumption and also actively generating energy or clean energy. It also empower the building owners to actually harvest solar energy to offset some of the energy used in the building itself, and also create sustainable and economical values in the building. So far we have more than over 400 projects worldwide since we started this product in 2000 in Japan. What is BIPV? It is actually a fully customized product which in terms of size, thickness, color, coatings, etc. It is actually a laminated glass, and in between it has these solar cells. Solar cells is like those are conventional solar panels, and it is actually incorporated or embedded with this interlayer itself. It can, with an air gap and another piece of glass, it can become insulated or DGU. Some of them is. So there are different types of terms or understandings of PVs. So probably most of us will understand what are these conventional solar panels. We are also looking into building applied photovoltaic in the center, and also these are building integrated photovoltaic. So one of the difference is that conventional, you only look into one size and one kind of standard panels. But if you look into building applied photovoltaic, it can actually have designs or colors which is able to compromise or to aesthetically blend into your building itself. Building integrated photovoltaic are actually integrated into the building, like even in your facade, your balustrade, your skylight, and even some of the walkways as well. I will show you more examples. So for us, AGC, we have 4 different type of product range. We are looking into Sanjo Vision, which actually allow lights to come in. It's like a transparent or semi-transparent kind of product. We have this Sanjo Origin, which is actually a black color, and it has actually good high energy efficiency. Next, we have Sanjo color, which in terms of any Arial colors, any Pantone colors, we can do kind of color matching. And if let's say you like to have your logos, your designs, or any pictures you want to put on your facade, we have these Sanjo designs, which can print or incorporate these designs into your building. So one example in terms of net zero building I will share is this AGC Kashima plant. So this is actually an office building, total floor area 1,435 meters, a floor of 2 stories. What happens is that this building is actually looking into net zero energy building. However, with the energy savings, like using your these low E, your raw materials for these heat insulations, and even with other materials wise, you aren't able or we still unable to meet this net zero. Next, we want to create some energy using, which is using this Sudari or Sanju Sudari, and also on this rooftop conventional PV, and that we are able to do, or we have these energy reductions of 114.7. So this is like how you see it, existing building with the aircon, ventilations, lighting, those are hot water supply and elevators. So the energy saving is actually only 50.4, and including those triple low E or triple cool low E DGU, and those are raw materials. So next step is that this could not achieve with the rooftop PV. Therefore, the architects actually introduced this vision area, whereby carefully study and also aesthetically appeal to use this Sudare on the visual area to make this into a zero energy building. You can see that with the readings or with the data, it means that just with the rooftop, it won't be able to meet this energy generate ZEB. And this is how the overall or overview of the building itself. With the lower iron glass or these are Sudari, the power generations or these results is helping them to do some kind of cost reductions in terms of in year 2018. So this is how it looks overall view. You can see that during the daytime, you actually will not be able to see how these blinds or these Sudari affect the overview of the building itself. We also have one project reference in Dulwich College, which we call this the greenhouse. This is actually also a net zero energy building, 6 stories with a rooftop garden. Sidewalk actually contributes to about 40% of the on-site renewable energy source. The rest of it is actually coming out from the nearby rooftop PV, and is actually certified as the Green Mark Platinum Zero Energy by this BCA. You can see that the building is actually tilted to angle. It actually used to maximize the angle to actually have a low glare impact on the surrounding HDB. It also gives you a good wind driven for the rain to actually flow down and have this kind of self-cleaning kind of technology, and also having this sunlight to actually penetrate into the building to create this kind of natural lightings, and also the wind to actually flow through the whole building itself. So this is short video to see the actual building which is already built since year 2025. 2024. So this is how the fins looks like on the east side shading. It actually have a good blockage of the glare, which happens to block off some of the glares experienced by our nearby HDB. Total area 382 for the fins area, and the skylight area is about 1,000 meters square. So unlike if you're using conventional solar, so you can see that on the skylight for the left side of the picture, you can still utilize the areas below of the rooftop area, and there is also purposely to have a less dense kind of solar panels on the area whereby the glass or the trees will be glowing, so that it creates kind of different look or different feel, and also enable the glass to grow well. And on the right side, you can see that these are all on the fin areas, about 340, and gives you a capacity of 48 kilowatt. And our project reference, we have, this is actually a first project in Indonesia that we have is Bank of Indonesia in this IKM. this is actually a new capital, which actually I would understand the government wants to have a sustainable urban development, and also want to incorporate kind of green space, renewable energy source, and also water management source into this building itself. So I think this building is actually completed in early 2025. You can see that these are some of image we have taken. It uses both our glass, these are Tissan Lux 508 and 108, and also our BIPV total 244 different size or different shades of panels. So this is also a short video clip of how or the skylight you see on this building itself. It gives you a good energy of 23.3 kilowatt peak. And beside it is actually using Tissan Lux, which actually is a good light reflective kind of glass on the building itself. And I think once it's completed in phase 2, this will be looking very. So this is just the skylight top view. So we have other projects reference as well. In Amsterdam, we look into a building whereby it's using black panels. These both are using black panels on the cladding itself, giving you energy and also meeting or giving you a aesthetic look of the building. If let's say you want designs, like on the left side is this TNO building, whereby it uses designs to come out and also having a good energy. And on the right side is this Shell Technologies Center, a LEED Gold certified building. All those designs or patterns you see on the rooftop facade is actually energy generating kind of designs. So in Indonesia, we have S Sanjo also comprised with this SNI. So what we understand is as of 2021, all crystallization crystallized silicon PV to have this mark with this IEC's SNI IEC 61215. So we probably says that in terms of quality, we have a good control, we have a good services or comprehensive services from sales to project management team, and we are also very much looking into the safety features in terms of fire regulations, building regulations, or even electrical engineering or other regulations. We are making sure that our product will comprise to it. I think that's all that I have to share. Session. Thank you very much.
Thank you very much, Mr. Tan, for your valuable presentation. The next, we will invite Mr. Indo Permana Putra from Sanken Setsubi Kogyo. I have to remind that each of the presenter will have 20 minutes to deliver the presentation. So, Mr. Putra, the floor is yours.
Ya, selamat siang semuanya. Pertama, izinkan saya untuk menggunakan bahasa ya, karena event ini event khusus spesial untuk Indonesia, dan apa yang ingin kami sampaikan agar mudah tersampaikan, jadi saya akan menggunakan bahasa Indonesia. Perkenalkan, saya Indo Pramana Putra dari Sanken Setsubi Kogyo, Jakarta representatif. Judul presentasi kami hari ini adalah ZEP Technology for a Decarbonized and Sustainable Society. Pertama, kami ingin menyampaikan rasa terima kasih yang sebesar-besarnya atas kesempatan yang diberikan untuk memperkenalkan teknologi ZEP kami. Waktu yang tersedia memang cukup singkat. Mohon maaf, dilanjutkan. Ya, waktu yang tersedia memang cukup singkat, jadi saya akan coba menyampaikannya secara ringkas, namun tetap menyeluruh, dan kami harap Bapak Ibu sekalian dapat memahaminya dengan baik. Berikut adalah konten materi yang akan kami sampaikan hari ini. Sebelum masuk ke materi utama, izinkan saya untuk memperkenalkan perusahaan kami. Sanken Setsubi Kogyo berdiri sejak tahun 1946, dan tahun ini kami genap berusia 79 tahun. Kami bergerak di bidang perancangan dan konstruksi sistem tata udara, sanitasi, serta instalasi kelistrikan. Sebagai perusahaan yang telah tersertifikasi sebagai ZEB Planner, kami juga terlibat aktif dalam perancangan bangunan Zero Energy Building. Kantor pusat kami berada tidak jauh dari stasiun Tokyo, hanya sekitar 20 menit, atau 2 stasiun dengan subway. Saat ini, kami memiliki sekitar 1.000 staf teknis yang tersebar di seluruh Jepang dan sedang menjalankan kurang lebih 300 proyek. Inilah beberapa proyek yang pernah kami tangani, antara lain pekerjaan air conditioning untuk Tokyo Olympic Stadium, serta proyek Mori Building berskala besar untuk sistem air conditioning dan sanitary facility. Belakangan ini, kami juga sangat sibuk dengan meningkatnya permintaan konstruksi berskala besar, seperti data center dan perluasan pabrik semikonduktor. Sekarang, saya akan menjelaskan secara singkat gambaran umum teknologi ZEB yang dikembangkan oleh Sanken. Pada tahun 2014, kami menjadi perusahaan pertama di Jepang yang berhasil mengembangkan net ZEB pada bangunan existing, yaitu Tsukuba Technical Center atau TTC. Tanpa menggunakan sistem pembangkit listrik tenaga surya berkapasitas besar, PV hanya 40 kW. Bangunan lain yang ditampilkan merupakan proyek kami tangani sejak tahap desain, termasuk bangunan milik kami sendiri. Kami juga telah mengembangkan berbagai jenis proyek ZEB seperti Neri ZEB di wilayah beriklim dingin dan ZEB Ready yang dibangun dengan biaya lebih efisien. Selain itu, kami juga terus aktif berkontribusi dalam berbagai proyek ZEB lainnya hingga saat ini. Berikutnya, saya ingin memperkenalkan secara singkat teknologi yang digunakan pada bangunan net ZEB di Tsukuba Mirai Technical Center yang sebelah kiri. Sebagai gambaran, TTC berlokasi di sekitar 40 km timur laut dari Tokyo, di kota Tsukuba Mirai. Bangunannya memiliki luas sekitar 2.260 meter persegi, terdiri dari 3 lantai, dan selesai dibangun pada tahun 1992 sebagai fasilitas penelitian dan pengembangan milik Sanken Setsubi. Seperti inilah tampilan luar dari bangunan TTC. Renovasi ZEB pada bangunan ini telah meraih berbagai penghargaan bergengsi, termasuk penghargaan dari Menteri Lingkungan Jepang. Bukan hanya itu, kita juga mendapatkan berbagai penghargaan lainnya. Ini gambaran dari teknologi yang digunakan. Warna hijau menunjukkan komponen yang berfungsi untuk mengurangi beban energi. Warna oranye menunjukkan teknologi pemanfaatan energi terbarukan yang membantu mengurangi konsumsi energi. Warna biru menunjukkan sistem visualisasi yang digunakan untuk mengoptimalkan pengoperasian bangunan. Dengan memasang insulasi dari luar dan mengganti jendela dengan low E double glaze windows, kami berhasil mengurangi beban panas tahunan sekitar 31%. Selain itu, exterior blind dipasang pada high side windows untuk mengontrol intensitas sinar matahari secara otomatis, sehingga beban panas berkurang tanpa mengurangi pencahayaan alami. Pendinginan dan pemanasan bangunan ini dilakukan dengan memanfaatkan secara maksimal sumber energi terbarukan, seperti panas matahari, panas bumi, dan listrik dari panel surya. Sistem pemisahan latent heat dan sensible heat pada pengondisian udara secara langsung memanfaatkan panas bumi dan panas matahari untuk proses dehumidifikasi, pendinginan, dan pemanasan. Sementara itu, HP di sini sebagai backup system. Sistem pemisahan laten dan sensible heat pada pengondisian udara di TTC menggunakan kombinasi antara radian panel desailing dan sistem dehumidifikasi. Berikut ini ialah foto saat radian air conditioning system beroperasi beserta thermal image-nya. Mari kita perhatikan, dalam ruang ber-AC pada umumnya, kenyamanan manusia sangat dipengaruhi oleh panas radiasi dari permukaan di sekitarnya, seperti dari ceiling, dinding, dan lantai. Dengan mengatur dan menyeimbangkan suhu di area radiasi ini, kita bisa menciptakan lingkungan yang sangat nyaman. Berikut adalah keunggulan dari ceiling radiant air conditioning system. Sanken mengembangkan dan menerapkan kontrol PMV yang sesuai dengan ceiling radiant air conditioning system. Kami telah mengembangkan dua jenis sistem dehumidifikasi, satu menggunakan decision coil dan satu lagi menggunakan sensible heat exchanger. Sistem dehumidifikasi dengan memanfaatkan panas matahari sebagai energi terbarukan lebih dari 55 derajat Celcius dan panas bumi sebesar 17 derajat Celcius. Satu lagi sistem dehumidifikasi yang kami kembangkan adalah kombinasi antara VRF dan sensible heat exchanger. Sistem ini digunakan pada bangunan yang tidak memiliki fasilitas chilled water. Melalui sistem BMS, kondisi operasional dapat divisualisasikan, sehingga memungkinkan pengoperasian yang optimal dan berkontribusi pada pencapaian ZEB. Sistem pemisahan laten dan sensible heat air conditioning ini tidak hanya dapat digunakan di Jepang, tetapi juga cocok untuk diterapkan di negara-negara ASEAN. Anda dapat melihat langsung bagaimana gedung-gedung yang dikembangkan sendiri oleh Sanken beroperasi secara real-time, secara online. Terdapat 3 lokasi, Tsukuba Net ZEB, Sapporo Nearly ZEB, dan Saitama ZEB Ready. Melalui platform ZEB Live, Anda dapat melihat kondisi operasional gedung secara real-time. Contohnya adalah TTC, di mana Anda dapat memantau suhu luar, suhu dalam ruangan, kondisi lingkungan di dalam ruangan, serta keseimbangan energi secara langsung. Indikator PMV dan OT digunakan untuk mengevaluasi dan mengontrol kenyamanan lingkungan dalam ruangan. Sistem latent and sensible heat separation air conditioning ini menggabungkan kenyamanan dan efisiensi energi, sehingga kini telah banyak diterapkan di berbagai bangunan. Contohnya gambar ini. Gambar ini merupakan gedung Balai Kota Kyoto. Gedung ini telah meraih penghargaan tidak hanya di Jepang, tetapi juga di Amerika Serikat dan di Inggris. Ini adalah ceiling radiant air conditioning system, Sanken system, yang digunakan juga di BCA Akademik Singapura. Sistem ini menggabungkan efisiensi energi dan lingkungan yang sehat serta nyaman, dan telah mulai diterapkan juga di kawasan Asia. Ceiling radiant juga telah diterapkan pada bangunan ZEB di sebuah universitas di Malaysia. Berikutnya, saya akan menjelaskan mengenai sistem latent and heat separation air conditioning yang telah diterapkan di Indonesia. Proyek ini merupakan hasil kerjasama antara Sanken, Arista, dan Universitas Katolik Atmajaya. Yang akan saya sampaikan ini adalah hasil studi verifikasi yang dilakukan di kampus BSD Universitas Atmajaya, sebuah institusi bersejarah yang sudah berdiri sejak tahun 1960. Ini adalah ruang kelas yang telah dilengkapi dengan sistem dehumidifikasi. Data ini menunjukkan kondisi cuaca di Jakarta yang digunakan untuk simulasi energi. Selanjutnya, ditampilkan data cuaca tahun 2023 di Jakarta yang mencerminkan tren peningkatan suhu akibat dampak pemanasan global. Dengan memasang outdoor air dehumidification system menggunakan general purpose product yang saya perkenalkan sebelumnya, dan memanfaatkan existing AC untuk menangani sensible heat load, kami berhasil menerapkan latent and sensible heat separation air conditioning system. Instalasi ini terlebih dahulu diproyeksikan dalam 3 decade oleh Arista. Air kondensasi bersuhu hangat sekitar 27-8 derajat Celcius terbentuk dalam sensible heat exchanger, sebagaimana ditunjukkan pada gambar. Ini adalah tampilan dari EMS, Energy Management System. Kami melakukan verifikasi dengan mengubah kondisi pengoperasian sistem pendingin. Tanpa memberitahu apapun kepada para mahasiswa, kami mengkombinasikan AC existing dengan sistem dehumidifikasi, serta mengubah suhu set point-nya. Kami kemudian melakukan pengukuran konsumsi energi, suhu, dan kelembaban ruang, serta survei kuesioner. Untuk efisiensi waktu, saya akan langsung menjelaskan secara ringkas untuk hasilnya. Berikut ini adalah item-item dalam kuesioner yang kami gunakan. Kami juga menyertakan pertanyaan terkait keluhan akibat pendinginan udara atau air conditioning sickness. Kami mengkategorikan survei partisipan. Selanjutnya, hasil survei kami rekap sebagai berikut. Berikut ini adalah hasil survei pada saat penggunaan sistem dehumidifikasi dan AC dengan pengaturan suhu 25 derajat Celcius. Hasil untuk kondisi pengoperasian lainnya juga telah direkap dengan cara yang sama. Mari kita lihat. Hasil evaluasi menunjukkan bahwa mengontrol kelembaban sambil menaikkan suhu ruangan terbukti meningkatkan kenyamanan dan penghematan energi. Dari hasil survei tentang gejala air conditioning sickness, kami temukan bahwa saat suhu ruangan dinaikkan, rasa lelah dan dingin di tangan atau kaki jadi berkurang. Artinya, ini bukan cuma hemat energi, tetapi juga lebih nyaman dan sehat bahkan bagi anak muda yang punya fisik kuat. Dengan menggunakan ceiling radian panel untuk menangani beban sensible heat, sistem pendingin udara tanpa tiupan angin ini terbukti lebih efektif untuk lansia dan kelompok rentan seperti pasien cuci darah. Di Jepang, sistem ini telah diterapkan di ruangan hemodilisa dan mendapatkan respon positif. Pihak rumah sakit pun telah mempublikasikan efektivitasnya di berbagai kesempatan. Sistem air conditioning dengan pemisahan sensible heat dan latent heat menggunakan ceiling radian panel yang telah kami perkenalkan tadi, sebentar lagi dapat Anda kunjungi dan rasakan langsung di Jakarta. Arista telah menyiapkan kantor khusus di kantor pusatnya yang menggunakan sistem ini. Jadi, bagi Anda yang tertarik, kami sangat menyarankan Anda untuk datang dan merasakan langsung kenyamanan dari ceiling radian air conditioning ini. Saat ini kami dalam tahap final adjustment dan akan segera dibuka sebentar lagi. Perlu kami sampaikan juga bahwa Arista memproduksi ceiling radian panel ini 100% buatan Indonesia. Jadi untuk kebutuhan dan konsultasi ke depan terkait sistem ini, dapat langsung menghubungi Arista. Poster ini adalah salah satu yang kami tampilkan dalam pameran di Bangkok pada awal bulan ini untuk memperkenalkan ZEB. Teknologi ini fokus pada pengurangan konsumsi energi melalui outdoor air treatment yang efisien. Akhir-akhir ini kami banyak menerima permintaan terkait sistem pemisahan latent heat dan sensible heat yang sangat cocok digunakan di pabrik produksi, baik untuk penghematan energi maupun mencegah pertumbuhan jamur. Dengan melakukan sedikit renovasi pada sistem AC yang sudah ada dan menambahkan pengolahan udara luar yang sesuai, kelembaban di luar ruangan bisa dikendalikan, sehingga produktivitas meningkat dan konsumsi energi berkurang. Poster ini menampilkan salah satu contoh produk yang memang dirancang untuk kebutuhan renovasi seperti itu. Dalam waktu dekat, sistem pengolahan latent heat ini juga akan tersedia di Indonesia. Jadi jika Anda sedang merencanakan pembangunan baru atau renovasi besar, kami sangat senang jika Anda mempertimbangkan solusi ini sebagai bagian dari upaya penghematan energi dan pengurangan emisi karbon. Ya, pada kesempatan kali ini, kami telah memperkenalkan salah satu teknologi ZEB yang dapat berkontribusi bagi Indonesia sebagai leader in decarbonized and sustainable society di kawasan ASEAN. Kami ingin menyampaikan juga apresiasi yang sebesar-besarnya kepada Arista dan Atma Jaya atas kerjasama dan dukungannya dalam mempersiapkan presentasi hari ini. Sekian dari saya, terima kasih atas perhatian Anda semua. Selamat siang.
Thank you, Mr. Putra. What an interesting presentation. Continue with our session. We will invite the next one is Mr. Mombang Sihite from Aspil Corporation. Mr. Mombang, the time is yours.
Thank you very much. My name is Mombang, as a representative of Aspil BGTC today. Let we start for the company introduction. As you know, the Aspil BGTC is a representative in joint venture company in Indonesia. That our company is the Aspil Corporation office headquartered in Tokyo, and we have been 119 years that we are staying in the 24 country, and that our president is the Kiyohiro Yamamoto. That our business segmentation is the three, is just the building automation, advanced automation, and light automation. As I report you that almost in the ASEAN country, we have the representative. And as I said, report that is three portfolio, three segmentation. Part is this building automation. This is related to the office, shopping mall, data center, hotel, airport, and anything, etc. And also advanced automation is related to the plant and industrial. And third is just the life related to pharmaceutical and related to the human. Aspil concerned about the technology and the human service. As you know that to install the BMS or BS, the more important is that how is after sales. The build BMS is easy, but the after sales is more important how to maintain the system. Aspil is also concerned not only for to provide the system, also we are looking for the sensor, also the daily operation, and we also use the big data to based on the new technology AI and ML. Aspil BGTC Indonesia already 50 years in Indonesia, 23 years as a distributor before 1997, and since 1997 until today, already 27 years, we are here for Indonesia. Already installed more than 650 BMS in Indonesia in the office towers. MRT, LRT also, super mall. If you go to the Senayan City, Plaza Senayan is just one of our install base. Also, we support the Green Mark and build the gold like World Trade Center 2, Menara Astra, World Trade Center 3, and also we are provide like more building. That we are second is the Aspil contribution to carbon neutrality. As you know that we are three concerned about the energy conversion, also energy saving, and negative emission. So we are start about the energy saving. The energy saving in our business concern to support the decarbonize. You see about the ASEAN, the GDP is going about 3.8. The population is 0.6%. So how we are going to reduce that into 2020, the 22% is coming from the renewable energy. In 2050, is going to 38 the renewable energy. So how we are as Bill supporting the country, each country to making zero in the carbon net zero carbon. Let we start the case study Singapore. As you know, the office is just the almost the biggest percentage the consumption energy, commercial and services about the 36.4%, and the industrial is the of course the 42%, but like household 15.6%. But if you go to the typical office building, the cooling is consumed about the 60%. The commercial building like a office, hotel, hospital, shopping mall, is this the 60%? I think just 15%. Ventilation is 10%, and the lift escalator also 10%, and others 5%. This is the typical office building energy use. So, as we report the ESCO, the ASPIL is not present just technology, also the solution. This morning session about the audit energy in the building. Also, we are using also the same of kind of the, when we are propose energy saving, we have the like first energy health check 1 and continue energy health check 2. But normally in Indonesia, energy health check 1 is free. No claim, no pay for this energy health check 1. So by this schema, so we have the finally how we are propose this energy saving company, that we are always based on the guarantee. If we are calculating the potential energy saving, we always to make amount as our guarantee. Means if we guarantee, let's say 1 million, so if achievement less than 1 million, we have to pay less by our guarantee base. This is our business model for energy saving company to support the net zero carbon in Indonesia. So how about the ASPIL technology to support B and net zero carbon? As you know, the total system should be mandatory to implement in the building. Not only water side, also the air side. We are combined by integrated technology. So this is the chiller plan about our new technology. Normally in the building has chillers sequencing control or chillers performance management. So by the existing system, now we have provide the new technology. This is we call it the digital twin. Digital twin is the like simulation tools by live. Is not offline, but it's the online to looking more potential saving by the optimization and the evaluation, adjustment enhancement, and operation enhancement and the visualization. So the estimated energy consumption we can know to reduce the energy consumption. This is the new technology. So digital twin, one of the solution how to looking the more potential efficiency in the building. If by because the 60% is coming from the cooling, from 60% we are concerned how to reduce about the 30%, means 18% from the total is become energy saving. But how to achieve this is the I think digital twin the one of the solution. How to making the actionable based the live integrated the chillers control with the digital twin. This is the one of the solution I think. So this is the how this working for integrated, not only sequencing, also how to using in the night time This is make the PWT, it is the variable water temperature control, is the most important. And volume also one of the solution in the digital twin. We can simulate to making most efficient the operational of building. In normally, the AI/ML is like just sensor, but now by the new technology, AI can analysis about the working performance of the building, like daily time, daily mode, especially like a shopping mall. How about the weekday, weekend? This is the, by the AI, we can combine, become input to reduce the energy consumption. Now in the building, normally is interior control, one of the simple one, the on off. But the HU is not only one point sensor. It's just like how to making the any independent variable air volume is become input to drive the motor of the HU. This is the concept of our PAP. So normally in the conventional, just one sensor, pressure sensor in the point in the more static button, and after that this is become input to drive the HU. But this is the new technology. It's not enough making the multiple sensors to drive the HU. So this is the sample. Normally in the by one sensor, this is the static pressure. Now is if HU, all zones are comfortable, less energy consumption. This is the variable static pressure by the as-built technology. So now also outside digital twin application become the new model in the building. If we are concerned about the cooling, now the potential, how about lighting? How about the elevators? This is the, by the AI and ML, is more achievable to support the zero energy in the building. This is like a draft. Normally, if we keep the constant, it's just the consume is the green. But if you use the by variable for the HU, this is the become less. This is the green is like a saving. This is the sample. Is 14 to 16% become reduction of the energy consumption. So digital twins is IBMS become new concept for the zero energy building. I think in the futures, not only about the cooling, but also as a total building, how to making virtual simulation by online to making more achievable to the target zero energy by PSC, integrated lighting, integrated elevator, also others facility. So this is the building energy optimization. Normally the diagnostic also we are using. Also the smart by the utility energy management, space management also it become integrated, and others the services application. This is the how the integrated the multifunction IoT sensors, also various IoT device by the IoT technology network. Like space is concerned about the energy saving by starting from the smart lighting control, smart air conditioning control, and smart cleaning operation. I think this is the latest of our presentation. That also we has the new technology to implement district cooling. We are popular in Singapore. We are a lot of the experience, also reference in Singapore and the district cooling. I think when the building is the super block, I think to support the GEB, I think implement the district cooling one of the solution. Indonesia business model become to provide this district cooling. I think the user no need to provide the financing because many financing company to build the district cooling is available now in. I think thank you very much for my presentation from us, Indonesia.
Thank you very much, Mr. Mombang, for the presentation. And now finally, we will invite the last presenter for the session. We will invite Mr. Masato Yosomiya from Mitsubishi Electric. Mr. Yosomiya, are you here with us?
Good evening, everybody. Can you hear me?
Yes, very clearly, sir. The floor is yours. Thank you.
Okay. Good evening, everybody. My name is Masato Yosomiya, and I'm from Mitsubishi Electric Corporation in Tokyo, Japan. And I'm an engineer of air conditioner. Today, in this presentation, I will mainly explain about energy saving technology for air conditioners to achieve ZEB in ASEAN. At first, let me introduce our company, Mitsubishi Electric Corporation. Our company is established on January 15, 1921, and the company profile is listed left side, and sales for fiscal year 2024 was 5 million and 521,711 million yen, and the number of employees will be 149,914. And we are a general electrical manufacturer that handles many things from heavy electric equipment to home appliance. The air conditioner business is one of our focus areas, and we product many equipment such as room air conditioners, commercial air conditioners called package aircon, and IT cooling and ventilation. And these devices use heat pump technology that has a low environmental impact, and product that can contribute to carbon neutrality. This slide shows our company's efforts towards carbon neutrality. We are working towards realizing a carbon neutral society through three main areas. One is achieving circular economy, and one is utilizing digital technology, and one is high efficient product and systems. And we will I will introduce a ZEB demonstration case in Japan as one example of effort towards becoming carbon neutral. A four-story building like this with a floor area of 1,915 square meter and floor area of 416 square meter has been built in Kamakura City, Kanagawa Prefecture, in Japan. And from January 2021, a demonstration test aiming for net zero is being conducted. Net zero is typically a two-story building, and achieving net zero in such a large building is a big challenge. And if we want energy conservation too much, there will be case where building do not function properly. In this building, the efficiency of each facility, such as air conditioner, ventilation, and lighting, is improved. And in addition, a technology that use DC power supply, DC power supply equipment to directly use the DC current generated by photovoltaics. And in addition to achieving net zero energy saving through operationally energy saving using various sensors, we are also working to maintain values such as improved business productivity, comfort, and convenience throughout the building's entire life cycle. This slide shows the design process towards achieving zero. We designed with the concept of hierarchical approach that maximized the use of passive design, which is an architectural method, and superposition active design, which is a method of building equipment and control, and also integrated energy management technology at the operation stage. And this building utilizes digital twin technology to performance energy management while simulating energy and comfort. By inputting 3D CAD drawing called BIM, the digital twin can be operated to simulate the operating status of building facilities and environmental factors such as temperature, humidity, and brightness, making it possible to predict changes in comfort. And this is the energy performance of this building. We have achieved energy saving about 62.5%, and achieve net zero about 500 megajoule per square meter per year, including power generation by photovoltaic, and with the greatest effect coming from energy reduction in lighting and air conditioning. In terms of air conditioning, we are reducing energy consumptions through measures such as reducing the air conditioning load by strengthening insulation, highly efficient heat source, and radiant air conditioner, and latent and sensible heat separation air conditionings, and human sensor and air conditioning design using relaxed air conditioner space. And although this is design value, energy saving achieved in the demonstration project exceeded the planned values. Next, I will explain about the energy reduction of air conditioner in ASEAN. The key technology towards carbon neutrality, carbon neutral 50, is introduction of renewable energy, the use of zero emission thermal power such as hydrogen and ammonia ammonia and energy management, and reduction of energy consumption such as zero energy buildings. The lower left graph is a trial calculation of energy consumption in office in Japan and ASEAN, and it can be seen that the ratio of air conditioner is large in ASEAN from Japan. This main reason is due to the use of air conditioning all year round and the increasing load to the use of low room temperatures. Generally, room temperature in cooling mode around 26 degree in standard in global. But as you can see from the lower right graph, many ASEAN countries like Jakarta, Hong Kong, Singapore, Taipei, Bangkok, their country use air conditioning with room temperature between 22 to 25 degrees. And this slide mainly describes energy-saving air conditioning technology that are important in ASEAN. In order to improve the performance of the heat source, it is effective to use a highly efficient heat source and to lower the condensing temperature by spraying water. And it is also important to reduce the outside air load through ventilation. To achieve this, it is effective to use total heat exchange ventilation or control the CO2 concentration with a CO2 sensor. And we think humidity control is important to raise the set temperature, and we recommend latent heat and sensible heat separation air conditioning. And in addition, improving the air tightness and insulation of buildings also contributes to reducing the air conditioning load. This is an example of a highly efficient heat source, a technology called multi-port compressor. By providing light side picture, by providing a multi-discharge port inside the compressor, unnecessary compress is eliminated and efficiency is improved during intermediate loads. The heat source unit with this compressor has an efficiency improvement of about 29%, adding improvements to the heat exchangers. In this case, EER is 6.54 to 8.43 in central graph. And this is energy saving technology that use human presence sensing called, this is total heat exchanger type ventilation system known as the